Okay, so I'm just gonna explain my Wordle code in case anybody asks, so I will have this ready and no one will, and I will be able to just give this to everybody as to how my Wordle code works. Okay, so first thing you have to understand about Wordle is that there's two types of words. There's firstly a list of guessable words, and there's a list of possible words. So the guessable words are the words that will never appear as a Wordle, but you can still guess when you're playing Wordle, right? So you're gonna have a list. And this list it's approximately 13k words long. And then you have this list of possible words, which is again the words that might appear as the correct answer when you're playing Wordle. And this is about 2k. And so I'm going to call this value m and this value n, and I'll explain what we use that for later. So now, to determine which of these words in the guessable word list is actually the best word, let's say we look at this word and we want to determine how good is this word. Okay, well, what my algorithm does is it goes through all the possible words, right? And we go one by one and we assume, let's say first we assume that this top word is the actual word, right? Then what would our guess return in terms of feedback, right? So it might, for example, return a sequence of, I don't know, yellow, green, black, 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 right? And my code will remember this response as YGBBB. And then you go through all of them, so you get different responses for all of them. So maybe for this one you get B, 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 G, and then this one you get B, 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 G, and then maybe the next one you get the same one as the first. You get Y, G, B, B, B. Now, what do you do with these values? Now, we're going to put these into bins, right? So in bin 0, or I don't know if it's better to think of it as, I don't know. Let's just call this the GGGGG bin, right? And then we have like more bins, GGGGY, all the way down until we have all 243 possibilities of bins. So we end with B, 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 B. And we're going to go through this list of possible words and we're going to tally them up. So let's say somewhere in this list, we have a GGGG. Maybe somewhere else we have a GGGGY, or maybe we have a few of those. And then, so we're going to keep going down, blah, 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 blah. And then, I don't know, just some random numbers. And we're going to label these. I'm going to call this N1, and this one N2, and we're going to go all the way down. And then this is going to be the last one, which is N243. And now I ask, how many, if I were to guess this word here, and I were to, let's say, observe B, 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 what does that tell me? That tells me that the only possible remaining words are all 14 of these words that had B, 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 B in them, right? So the probability of seeing B, 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 B is N243, which is the number of words with which would respond with B, 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 divided by the total number of words N, big N. So this is the probability of seeing this. And when you do see this, you would remove 14 words. Or sorry, you would return all but 14 words, as in those are the number of words you would eliminate. So this would be N minus N243, right? So this is all of the remaining words that are left after you see B, 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 B. So now, all I have to do is sum over all the possible words. So if I replace this with, the sum index I, this is now a measure of the expected number of words I would eliminate by guessing this word here. Right? And so one thing my algorithm does is I just take this factor of n out because it's just a constant factor. And so this is the actual formula I use, ni times n minus ni. And so I would go compute this value. That's kind of a bad rectangle. Anyway, I would compute this value for every single guessable word. So this would be, I don't know, 503,640,000 or something. And then this one I calculate, I don't know, 11672. And then I'd go through all the words and I simply pick the word with the highest value, which is the best guess possible. And so that's basically how I generate this list of the best possible words, and it turns out the best one using this algorithm is row 8. And so to continue this, right, so this is just to get the first word. After I do this, if I put this into Wordle for real, I will get a response, and maybe it actually turns out to be B, 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 B. So there's 14 possibilities left. What I would do next is I would go through the possible word list, and I would cross out all of the words that were not B, 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 B. And then I would repeat this process, except now, every time I look at a guessable word, I have less possible words to check through, and therefore the value that I assign to each guessable word will be different at every round, but it will be the optimal guess for that round, given that we've eliminated this set of possible words. And so I keep doing this, and based off this, my algorithm has never taken more than 5 guesses. I have not run my algorithm overnight to check if this is actually the case for every possible word in this possible word list, but I'm willing to go out on a limb and say most likely there are very, very few words, if any at all, that take 6 guesses for my algorithm to find. So I think this is quite an efficient algorithm. Another version of this game is Absurdle. And then Absurdle will always give you the response for which you have the most possible remaining words left after that response. So for example, if let's say we're going through this algorithm and you had, I don't know, G, G, B, B, B as an example. Maybe this is not such a good example because there's a lot of G's here. But maybe Absurdle's algorithm saw something like B, B, Y, B, B, and saw that, oh wow, it gives you 200 remaining options. It would pick this option because it would leave you with the largest possible word list remaining. So so instead of using this formula that I've boxed here to compute for Absurdle, I have a separate code which solves for Absurdle. So instead of taking this value, it looks through this whole list here, and it says, okay, well, Absurdle is going to give me this thing. So I'm going to assign this word 200. And then, I would, again, go through every word and see. If I'm playing against Absurdle, how much am I going to... what is the worst case scenario? And then I would pick the value in this list that gives me the lowest value, because that's what I know Absurdle will give me. And therefore that would narrow down the search as much as possible. Now both of these algorithms, both that solve Wordle and Absurdle, are both greedy. So there's no guarantee that these are actually the best algorithms, but I think they're pretty good. Also, I'm trying to create a search algorithm to solve every Absurdle solution in 4 guesses or less. So that's gonna be my next project. Okay, that's pretty much it, and